pie graph or circle graph. Sometimes also called a pie chart, I think is what something I've heard them called. So, get my pen working here. A pie graph or circle graph is circular shaped, obviously. It's used to show the percentage of each category in relationship to the whole. So you have to actually find the total of everything and then use your numbers with your total to find the percentage. Okay, so the first thing we want to do is find the total. Because that is the entire whole set of data, right? So what we're going to do is take these numbers right here and add them together. So 33 plus 35 plus 26 plus 46 plus 60. Now, do you think this total number is going to be the same for every set of data? No, it's not. And so that means you're going to use a different number to do this process depending on the total for the data you're working with. So this set of data is a total of 200. So now what we're going to do is take each of our numbers and divide them by 200 because that will help us find the decimal, and then we can turn that decimal into a percent. Does that make sense? So take each number and divide it by 200. And technically this first column is asking us for the percent, but why don't we do a decimal first? And then we can change that decimal to a percent. So we're going to do decimal, and then we're going to do percent, and then we're going to do an angle. So here's why. In order to make our pie graph, we need to know how big to make the little angles in the middle of our pie chart for our sectors. And so we need to find what percentage of 360 each one is. So it doesn't matter what this number is right here because this is always going to be 360 degrees in a circle. So we're always finding that angle out of 360 degrees, right? You guys remember that there's 360 degrees in a circle? Here, this is hard to read, so I'm going to make it like skinnier, see if it shows better. That's a little better. Okay, so for each one of these, we take the numbers, we divide by the total. So why are we dividing by 200? Because it's the total, right? You understand that? So 33 divided by 200 will give us 0.165. 35 divided by 200 will give us 0.175. 26 divided by 200 will give us 0.13. If you don't believe me, throw these in your calculator, see what you get. 46 divided by 200 is 0.23. And then 60 divided by 200 is 0.3. You don't really have to put a 0 after that, even though it would be half of the 60, which is 30. Okay, so those are the decimals. Is that the percentages? Do we put decimals on our pie graph usually, or do we do percentages? We usually do percentages, right? But hey, these decimals are the numbers you're going to multiply by 360 to find the angle, so just keep that in mind. So how do you find a percentage from a decimal? Do you remember? Yeah, move the decimal place to the right, actually, but that's fine. To the right twice. You can also get it by multiplying by 100. So it would be 16.5% and 17.5% and 13%. And 23%, and 30%. Now, if you did this right, these numbers should add up to 100%, right? Because we want the entire circle, the whole circle. We're comparing each percentage compared to the whole, and the whole is 100%. 100% of the data. Okay, so now the tricky part. Let's find the angle that would be represented by each piece. So what we need to do is take 360 degrees and multiply by, you can either use the percent button in your calculator, like go 360 times 16.5% equals, or you can use the decimal, because that's what the percent button in your calculator does. If you notice that, when you type in a number and you hit the percent button, it just moves the decimal over for you. So you're either going to use these numbers or you're going to use these numbers with the percent button in your calculator. And you're going to multiply those times 360. And that's going to give us the angle for each one. So if you guys will help me out, find those numbers for me. Okay, so 16.5%, when I multiplied the 16.5 with the percent button times 360, I got 59.4. Did you guys try that? If you try that in your calculator, make sure you can get that correct angle. All right, so as we went through this process as a class, we found 63 degrees for this one, and 46.8 for this one, and then 82.8 for this one, and then the last one was 108. And if you were to add these all up, guess what they're going to add up to? They will add up to 360 degrees total, because that's how many degrees we have in an entire circle. Okay, here's our circle. We want to try and find the center best we can. You can use a ruler to measure the radius and make sure that you've got it in about the right place, or you can just wing it and call it good enough. If you want a better circle graph that's more accurately drawn, Google Sheets or other spreadsheets like Excel allow you to put numbers in, and then it will create circle graphs for you from those numbers if you choose the right graph option. Okay, we're going to also sketch in a line somewhere. I'm just going from the left, it doesn't really matter, from the circle itself to the center. And then we're going to start using that line to build our segments at each of these angles. Okay, now we need to figure out the middle angles in our circle. Those are called the central angles that match up with the angles we just found. Now notice how the angles and the percentages are different, because percents are out of 100 and the angles are out of 360. So those are going to be different numbers, right? So this is called a protractor. We can use a protractor to help us measure angles accurately. So that's one way we can do this problem. Another way we can do this problem is just by kind of estimating and giving approximate values for angles. Like 23%, for example, is pretty close to 25%, and 25% is a quarter of our circle, or about 90 degrees. See how it's 82.8 degrees? So 90-degree angles are pretty easy to draw because it's what we're used to with that corner of a square. And so you could use that to help you estimate the angle instead of being precise with a protractor. Okay, but if you want to use a protractor, let's remember how to do this. So you take the very center of your protractor and line it up with the center dot on the circle, and you line up the edge of the protractor, or the line that says 0 or says 180 or indicates those numbers, along that line you just drew. So our first angle is 59.4 degrees. I'm just going to just quickly estimate where 59.4, approximately 59 degrees is. I don't think it has to be incredibly accurate. We're just trying to get an idea for how to do this. So 60 degrees, 59 degrees, somewhere in there, right? So I put a dot where that angle would be. Now I'm going to move my protractor so that I can use the edge of the protractor as a ruler. And now I can draw a line between the center and that point that I just sketched. I don't know if it'll let me. Wonder if I move it there if it'll let me. Yep, there we go. Oops. It's crooked. Try a different one really fast. Go narrower. Try again. Well, that's not really letting me use it like a straight edge ruler, is it? Okay. Well, you guys can use it as a ruler. I'm going to use my line drawing tool. That is for sure to make a straight line for me. Okay, so you can continue this process, measuring those angles with your protractor. Set this out of the way, and then you want to label your sectors. So this particular sector was volleyball. So I'm going to write inside of it volleyball. And I'm also going to write my 16.5%. So someone looking at my graph can quickly see the size of the sector to relate it to the other sizes of the other sectors, but they can also see the actual number written there. Okay, I realize I kind of shortened that from our chart because it says playing beach volleyball, so I just shortened what that said. Okay, so continuing onwards, see how fast I can do this. Maybe I will pause my video. Nah, I'll just keep going. Okay, so let's see. Next angle is 63 degrees. Put all my dots in first. So here's 63 degrees. There's a dot for that one. Now I'm going to move this. And of course, I'm going to draw a line there in a minute. Okay, the next angle is 46.8. So I'm going to do 47 for that one. So 47 is between 40 and 50. So about right there. Then my next angle is 82.8. So I'm just going to try and do like approximately 83. I need to move my screen down so I can see this. So 83 is like between 80 and 90. That's the one I said that's almost like a right angle. So that would be about right there. Then my last one is 108. I shouldn't really actually have to measure that one because everything else has already been done. And so my 108 should just kind of be already done with what's left. It's close. If I look at it, look at that inside number, it says 110. So I wasn't incredibly accurate because 108 is going to be a little bit smaller than that, but not too far off. So like I said, the last angle you shouldn't have to measure if you did the other ones, you know, properly. Okay, let's put our lines in there. So there's a line going here that would go through that dot. There's a line going here that would go through that dot. There's a line going here that would go through that dot. I don't really need those dots anymore. It's not going to just let me erase them. I'll have to select and delete them, so I'll do that in a minute. Okay, so I'm grabbing my pen again so I can label all of these sectors. What was our next one? I've got to look at my chart. Maybe I'll expand my picture so I can see it easier. So the next one was kites. So that's 17.5% for kites. And then 13% for sandcastles. And then 23% for sunbathing. And then this one here, surfing, was 30%. So you can see how each section, the size of it tells us how popular things are, but the numbers also tell us what the actual values of the data turned out to be.